Okay, guys, anybody there? Let's see. Let's see if I move this off to the side. And, what is it already started it? Yep. Let's see if I move this off to the side. And, what is it already started it? Oops. Hello, anybody? Anybody, give me a second to catch up here. Give me a second to do some catch up. And I'm ready, caught up. Okay, you'll like this one. You will like this one. This won't be long. This will be short. And let's establish some, let's do a little quick. What I'm going to show is that free body diagram is what basically computer generated programs do, is that this artificial intelligence to help engineers now use their brain, that they don't have they can put their brain on a shelf, and they just used artificial intelligence. If we come to the OSHA report, we find that the software was used by Louis Berger is Adena, and to analyze the structure in accord with the FDOT requirements that the reviewer use software. So the FDOT requires the reviewer to use software other than the ones used by the designer. So this is reported that it's a requirement to use software and that you must use a different software. So that's not technically an issue, is it? Because you were told to use different software and told to use software by FDOT. FDOT had used software, FIG had used software Larsa 4D and Lucis, whatever. All right, so you have three different softwares being run here. Three different softwares being run to come up with an analysis, right? And Louis Berger software said, of all things, says Louis Berger discovered during the review of the design of the final completion stage of the structure that member one was subject to excessive bending moment. That member one was at the final completion stage. That number one would get a bending moment. And FIG agreed and introduced a couple of hinges in member one to alleviate the bending moment, stating that, showing and implying that number one is not a zero force member. That therefore, number 12 is not a zero force member, which I've always stated. That number 12 is load bearing, and so is number one. It's load bearing. Louis Berger also raised the issues of excessive compression stresses in members number 2 due to post-tensioning of the post-tensioning bars, meaning that when they put tension in member, let's grab it. We're in the report now. Okay. So when they grab the, let's do this. When they post tension, let's scroll down. When they post tension the structure, number 2 and number 11 here, that number 2 would have excessive forces in it by the post tensioning. Then a page counter to that is that's because of transportation for the overhang reasons. Fig agreed, right. Louis Berger also raised, it's going to come to you in a minute. Fig explained to Louis Berger that the post-tensioning is required during the movement phase to counter the tensile forces and the diagonal due to cantilever action during the transportation. If Fig had explained this to Louis Berger, then Louis Berger obviously didn't evaluate the proper transportation if he had explained this to them. So there shows a disconnect in what they think the structure is capable of and what the structure is being done, including during movement. If Louis Berger had to be told by Fig that, oh, that's for cantilever requirements, that shows that Louis Berger did not have an understanding of the structure. That's what it implies to me, extrapolation. After the main span was transported and seated in the piers, the post-tension bars will be detensioned. So this is very important. And so Louis Berger had no other significant comments. So Louis Berger did not even understand that they were used for cantilever counterforces during transportation. So it's an old moment, like, oh, okay, oh, I got it, whatever. But He didn't even understand it was for that. So how do you expect this person to understand the structure if they don't understand the structure? Now watch how, again, it says after the main span was transported and seated on the piers, the post-tension bars will be detention. That means 2 and 11, specifically 2. Louis Berger had no other significant comments. OSHA asked Louis Berger repeatedly to provide a peer review, and they could not. All right. So let's go to, this is number 11. This is spalling. Apparently, it looks like spalling to me. And this means that the loads are present. This appeared after they removed the formwork, as I think it's stating here multiple times or multiple ways. Obviously, no formwork is present. And I don't know if it's the base of the structure underneath the deck has the formwork still under here, but we clearly see no formwork at the photographic points on each end of the structure as they show cracks here and there. This will be nice, guys. You got to bear with me. You're going to like this. We're going to get to this number 11. You're really going to like this. You're going to see it so clearly. So when they removed the number 11, the cracks like hell appeared. This is sort of what I've said already, that once they did that, under here is a gap. We know about the gap there because Denny Page stated in a meeting that they needed to shim that. You'll see the significance of that in just a moment. Bear with me, and you'll see it no other way. This will get rid of all ambiguousness. That's my word that you may have. It's ambiguity. All right, so ambiguous. I like having fun with words. I told you guys that in many videos. Obviously, if this is the engineer BPA, obviously I insult them as being a clown, taking measurements off of a known point would have been these bolts. Trying to guess center line would have been just not very good. But he put it on an angle, and on an angle you get a different reading. This is the cracks like hell that we see them closed up. You're going to see the cracks like hell in a minute. You're going to understand it so simply. But first, I'm giving you the data first. They're the cracks like hell, and you're like, how did it happen? Well, magically, I have to go over here, guys. I apologize for offending any of the people over in this group. And yes, I will attack this group. And so magically, and there's a couple of them changing their minds here, but then they get cowered down, they get beat down to say, how dare you say that? Especially this guy that sometimes, so I don't throw the baby out with the bathwater. But when I do throw the baby out, I throw it out pretty hard. So in other words, just because I'm throwing this baby out doesn't mean I'm throwing out everything he states. I've made quite a few mistakes myself in my videos that I've correct each time. But this bullying thing here, I'm going to give a little bullying back. Second, it wasn't a criticism, but using factual information to back up that. This is what he states. Secondly, it wasn't criticism, but using factual information. So we don't know what's really factual in this whole damn content that we're getting from OSHA and everybody else. We assume it's factual or data, but we keep getting things like originally we all got sent on a wild goose chase. Never forget that by NTSB and FDOT giving us plans that were not stamped from 2016, presenting it to the public, and then all of a sudden they present 2017 plans with partial 2016 plans still tied to them current day. So, I'd like to see all of 2017 plans. Okay. So he states factual information to back up deck 1112 could have moved before number 9, 10, and canopy 10, 11. This is a crackhead. You call yourself a structural engineer? I don't know. So crackhead is a characterization. And so let's change that. Let's change that. Let me dial it back and say this guy, and when I say so my way of saying you're totally like, you're on drugs. You're so far off there, man. You're out in space. All right. You're so far off is what I'm implying, is that you're in space. If you're a structural engineer, I challenge you with $1,000 agreement that you cannot prove this statement. So I'm making this a YouTube video, and it's a contract. And so I contract with this guy that he has to give me nothing. I give him $1,000. So it's a win 100% for him. If he can show me that number deck 1112, that number 11 could push 12 off the deck without moving number 9, 10, or 10, 11. He's a structural engineer. He can't take my $1,000. He can't take it. Nobody can take my $1,000 without moving number 9, 10, or 10, 11, and with the data we have to show that this happened. He can't touch it. I find him bullying this guy. I told you some of the computer guys are pretty cool. I find him bullying that guy to be find him to be an asshole. So I'm sorry for my cursing and attack on that, but I've always attacked bullies. And so I come off like the bully when I'm attacking. That's right. I put myself between there. You guys know my background. You know why I put myself between between bullies and whatever. All right. So he did I think this is the guy, Charlie's name. I told you guys, I love the computer guys. They do some fun stuff here. So, I'm not saying this is correct or anything. I'm just saying, he goes out of his way, he finds the images, this is the thing there. You're trying to do some extrapolations, and I just find it, that I'm smiling because I'm pretty proud of it. This is pretty cool. I don't care if the guy attacks me, I'm still proud of it. He's using my string line, my lines, if you will. I think he has one here that he puts in place here, to show it. And then they beat his ass down in the comments. And so much so, I think he retracts it to some degree, which I wish he would not have. Stand proud. Stand proud of your belief. You should stand proud of your belief. Stage said something to the effect that number 12 looks pretty damn strong, didn't move. Now I'm gonna prove this to you guys, so bear with me. Well, he's got a $1,000 bet, but remember my other channel, how things work here, that I put this video up with the stones. Now I'm going to show you something that's going to be pretty awesome here using this, and you're going to understand what's taking place here. Who's watching? Hey, Embry. Like swimwear, baby. What's up, baby? Emwear's like here like swimwear. I haven't heard that one, but I kind of like it. I'm here like swimwear. It's a little rhyme. So watch how beautifully I tie this in with this. Remember that Denny Pate's meeting was that he wanted, why wasn't this shimmed? Why wasn't this shimmed? You good. I'm going to have a little fun. I got to be careful. YouTube doesn't like any, they're the new moral police of everything. So I got to watch cursing and everything. So this is a OSHA report. Let me get you this real quick. Scrolling. Rawhide. That's what the rhythm of that is. All right. So, and then I'm going to show you my little quick video, and you're going to see that, oh, shit, I get it totally. So first I've used OSHA report just now to prove that OSHA states that Louis Berger and Denny Pate came to agreement that number one is load bearing, that it has a bending moment in it, that it is load bearing, number one, which is down here at a site. Great. Number one is load bearing down. Yeah, this number one, load bearing, and they put and Denny Pate resolved it with hinges. We established that Louis Berger didn't know why the post tension was added in here, but stated it's going to create an excessive compressive moment inside number two. Denny Pate had to tell him, oh, that's for the cantilever when we're transporting. At that point, that tells you that we can extrapolate that Louis Berger doesn't even know couldn't even extrapolate why you would do that. So that shows Louis Berger's competence. All right, so that lack, their competence level. So I'm in attack mode today. I'm sorry, guys. I'm in attack mode. Louis Berger's I gotta, you know what? I just made a conclusive vow that I'm in attack mode. So it looks like I'm gonna stay in it for a minute. Wish I could come out of it. But that's the way I feel right now. That's the way I feel right now. So you're gonna get a little hit of that. All right, let's go on. Let me show you. I'm looking for a forget those cracks. We already know about those cracks. I went over those cracks so much. Like I said, I'm a crackhead now. This cracks like hell. This happened after they detention number 11. Just remember, after they detention number 11. You're going to love this, guys. So they detention number 11. This is number 11. I took liberty here. I changed the colorations. I didn't do anything else here. I added some bars here. I move this out of the way. I move this out of the way. All it is for plain reasons to show what's going on. Let's consider this number A, post-tension bar A. It terminates inside the deck. Number A terminates inside the deck. All right, so we're going to put it all together piece by piece real fast, not like one of my 10-year videos. It stays back here somewhere, right beyond. This is the end of number 12. Right there's the plane of, and I'll scroll to the bottom, the plane of number A, because it's at the bottom. La la la, la la la. Those forces, all this is wrong. That's wrong. Just wrong. It's wrong. The OSHA report is wrong on that. That's where I stand on that. They've got a lot of things right. They missed that one. Here's A. Look at that. It's behind the clamp force. The clamping force is behind and in the deck. In the deck diaphragm area. Well, that's not even a diaphragm, right? It's in the deck. Then we have more data to that to prove it's in the deck only. When the bridge failed, they took photographs. Yeah, they did some cleaning up, and we have to accept some of their deviation. There's number A, still in place. All right, still in place. Number 12 is sitting pretty right. So we know where number 12 is in relationship to this debris breakout. It's right about, well, let's go back to it. There's the end of that. Remember that. And there's the plate. You're going to get a clear visual of this, and then I'm going to show you the release. And I'm using their own I'm going to extrapolate that they have loads on number 1. So extrapolating, which I already said the loads on number 12 by default. There's no friggin' choice. This is cantilever. I did a video on that. It's for this cantilever to be, well, we know it's loads on there. You know why? Because there wouldn't be any friggin' reason to put any post-tensioning in number 11, right? We know there's on there because any of you guys, if any brains, know that you don't get to stick a cantilever out 33 feet with 2 post-tension bars and that much weight for free, along with the lower part of this deck, along with the weight of the rod. Crackheads who keeps saying it's zero. One more engineer writes me and tell me that's a zero force member, punch you in your eyeball. I have to say that nice eyeball because Google doesn't like that. Of course, let me apologize to Google. Of course, I can't punch them in the eyeball. They usually add it somewhere else. I don't mean it as a threat. Really, Google, come on. All right, so here's what we say is men, Google. Men do that. Say that to men. All right, men say that to men. We know we don't really mean it. You women in Google think that everything's a damn threat. All right, so and some of you women men in Google. All right, how's that? I told you I'm in attack mode. All right, so look, here's the end of this guy. Barely clipping inside 12. So if we use the cross section and also you use that VSL, so there'll be no deviation of the members, and we consider this an as-built because it's presented to us as an OSHA report. At the point this is presented in the OSHA report, I'm calling this an as-built, guys. Remember, we don't have as-builts, but I'm extrapolating. They're presenting evidence in an OSHA report, so we can extrapolate that this is evidence now. This is an as-built. That's my extrapolation. Of course, OSHA can say, oh, no, it was just a whatever. Well, then that would detract from their own report. I'm saying we're looking at an as-built. Okay, so this is just barely clips on the other side of into the diaphragm area. It's looking at the plane here, it just clips across that metal. Doesn't this look like it's out of alignment? This and this to you guys looks like it's out of alignment to me. So it barely clips it, and like it's angular. So somewhere, but it might be equal. Let's use this line here as our measurement point. And I use my mouse down here. About 3.5 mices. I'm going about 3 mices. Yeah, I like making up words. I told you that. Mises. All right, so number 1 here, baby. Look at this number 12. It's outside the diaphragm. During the build, outside the diaphragm, outside the deck. And when this was built, I'm trying to get the image in the background. Bear with me, baby. Bear with me. When this was built, out here is just this what I'm calling a blister. We know that this was built secondarily. First the deck, including this little blister, which means it had the post-tension bar placed in it. Along with so that's A. Let's put back B. So this will be B. terminating above the pipe. Let's now get you a plane line, and let's bring this over. That's the outside of 12. Here's the outside of 12. We're just going to use this plane line in the image. So now we have a plane line. What's left is this dissects the deck. My computer guy would like this over there, and he's not my guy. I don't know him at all. Don't even talk to him. That's left is, let's go with the deck. Oops, I got to go the wrong direction. Something like, yeah, I got to do what I got to do here. Let's see. So I'm taking a little bit of liberty there, trying to make these bottoms match up. And what's left is this, in the deck area, is this little teeny, well, if I can move that over where it really belongs. It's internal. And I can't, I'm doing some extrapolation because I can't, you know, the angle, I can't figure out the setback and all that. But this little triangle where my finger is, where the blue cross is, so I would slide this up to the deck area. And you got this teeny little weeny triangle that it goes through number 12. The rest of 12 sits on top of the deck and sits on top of this blister. This wasn't all made in one deal. So this is just a column sitting on top of the deck, sitting on top of this blister, sitting on top of this, which gets a little bit of clip in it, a moment, if you will, a reaction, because it does have some little bit of concrete in it. So imagine some post-tensioning going across it, just at that little bit of a section. Bear with me, you need the data for me to show you the video, and then you're like, oh, okay, I get it. So right here, hell with that. So right here, so we've got it. That's why I said, my stupid ass, I could have just done this. Since I'm using this as the as-built, I don't even have to take that much liberty. I can use it as an as-built. So this is 12. This is the deck, rather. This is 12, where you see this right here. So what's crossing right through, here's the deck. So here's 12. Let's do that. Can I get a triangle out of this? Can I get a triangle, baby, for $10? A triangle for $10 appears not. And you can't deform that. Great. Oh, I got a triangle for you. Can I get a straight line? So there's our, I'm going to go to the outside of it so we can see it uninterrupted. So this is the part sitting on the deck. This is on the deck. This is the triangle, the transverse of this. But keep in mind, this member here stopped. Yeah, I have to make sure you understand. It stopped here. This number 12. It was all poured together, so it's integral. But you see the paths, the load paths. But this is the only triangle in 12 that goes down, sits on top of the deck. The rest of this guy looks like this. As you can clearly see, it's got a peculiar shape to this bottom section. It's sitting on top of the deck. Keep that in mind. But the cross section inside that 12 looks like this triangle sitting here. And the rest of this guy is sitting. And let's change colors. I need you to see this so you can do this. So bear with me. You're going to love it or you're going to hate me. And if you hate me, well, I hate you too. I got feelings. Just because I'm a tough bastard doesn't mean I don't have feelings. I don't have any feelings. I'm like Embry. Hey, look, I got feelings. But you guys can never touch them. You can trigger me. That's not touching my feelings. That's messing with my conclusive files. 10 inches right here, approximately. So you can see that what's left now sitting on the deck with this transverse compression moment holding this part on the deck and on the blister is this clamping force. So the clamping force is holding this guy here, right? This blister is being held on there. If I remove the clamping force, well, and I don't have the shims under here, so no shims. How do we get no shims? How do we do that? Cool. So I have no shims here. The forces are downwards. You say, well, prove that, you son of a bitch. All right, well, give me a second. I'll get to it. I got you covered. So you see that's that little blister. This goes back there. I guess I can tighten it up a little more. So the area is somewhere like that, the load. And what happens when you release that load is this dead load comes down, as the report shows. And number one, the compressive moment. This is not, as any engineer keeps telling me, a zero force member. Bite me. If you think it's a zero force member, then you remove it. In fact, I got to go over here and do some trolling. I got to tie this in so I can prove to you guys what these guys keep saying about zero force members, which is triggering me to the point of a mental breakdown. Because I'm not having a mental breakdown. It just seems that way. So, hey, get out of there, Bruce, George, my cats. I'm going to beat his ass. Hold on a second. Hey, that wasn't the intent of that. Come out of there. I covered the couch with a tarp. And my little man climbed underneath of it. Little punk. All right, so, oh, shit. All right, hold on. Bear with me, guys. You'll like this, too. I got to be able to prove all my nastiness, right? I just can't be nasty because I'm evil. I woke up on the wrong side of the bed or something. No, I got to, he's got a trust system up here somewhere that he shows why it's a zero force member, this engineer here. And this is what happened. Magically, all their formulas, they just show the bottom of the bridge just sliding over like this. Look, just sliding off, causing all this shearing and all that. I'm like, well, what did it do at the top? You got this part moving on its own. And how come the cracks aren't in there? And where are the rebar and the reinforcement? What's it doing to this member here? Why is it still in place? Clowns, crackheads. This is a total different end of the structure. This lands totally on the diaphragm with no extending blister. It's 3 foot, whatever. It's 3 foot. All right, grow up. It's a totally different end. This lands totally on top of the structure. The other one sticks out. Well, who did this? That guy. See that? Don't throw out the baby with the bathwater. I like this. He did a merged picture of one end to the other. South end has a stronger joint, although it's vertically column. It's only 5% larger, but 3 foot diagonal. Oh, get out of here. It sits on top of the deck, you clown. And over here, it sits mostly offside the deck. Another structural engineer, the same guy, clown. All right. They're total night and day. They're two different damn structures, two different ends. I want to show you this so then I could go on about this whatever. Trigger. Come on. Oh, man. Well, they show it as a Warren truss, and they show a zero force member. They take out one of these damn diagrams they have up here. Man, I see that, and I had to click out of there. I'm like, oh, that's when I thought I was going to find something interesting. All I did was get triggered. Whatever. Hold on. It's a diagram I'm looking for. I have not quite read all this stuff. I bounce in and out. I kind of like the computer guy's stuff. It reminds me of DOS and my other man. A couple of you guys there, the computer guys. The structural guys reminded some people to write me on my channel, just trolling just burning me up. Looks like their comments writing to me, and you guys don't see it. I don't post them. I'm like, whatever, man. Just go play in your childish brain. You structural engineers, they just handed you your damn degree, and you must have got the damn engineering certificate when they were just handing them out, the PE. When they were just handing them out. Here you go. You're good. 1930s. All right. Frig it. I don't know where it is. It's, let me chase down. Give me one more second. Well, they're stating that these are zero force members. They don't count. And nope. You know what? Let me do this. I just want to do one back. All right. I apologize for putting you through this. Is this one back? I can never get this right. You guys come over here and look at it where they show a truss. with the proving zero force member, where they keep taking this out. This is a computer guy, so I won't hold that against him. That just creates shear. That would just tear the thing apart. It was his idea of what he thought they were talking about, recapturing the loads from the node from number 9, 10 to 12. Well, he did that. That would just shear that thing right apart. That's what he thought, I think. And it's okay. It's a computer guy. He doesn't know, and these engineers don't even know either. They couldn't. At least he tried. I have no idea what that was. Come on, baby. I'm bailing after we get to the bottom of this one. I'll bail and get back to my content. But everyone, they're arguing again that this is non-load bearing. This is a zero force member and zero force. Yet I just showed you in the report that this is load bearing. And no luck on. You guys got to come over yourself and find it then. What they keep bitching about zero force. Whoa, there's that one again. So the engineer states, but an excellent representation of what FIG had proposed according to page 76 of the OSHA report. FIG did not, this looks like a quote from the report, FIG did not know the reason for the cracks, but still expressed no safety concerns. However, FIG in this presentation alluded to a lingering concern about the structural inadequacy of the 1112 node, 1112, until the immediate pylon and back truss were completed. The pylon here and the back truss. FIG mentioned a temporary mechanism to capture the nodal zone. FIG option that opined it may be appropriate to transfer some of the loads off of 1112. FIG was to consider options to capture some of the forces from the node. FIG also stated that the prudent action is to share some of the load carried back to 910 and construct pylon down. See, to share the loads are coming back down 910, which I've always stated. He said this is an excellent representation of what FIG had presented. This is not what he would have presented. This would have been a shearing going on the bottom of there. The loads would have just torn this apart. So you structural guy, this is another one of you suck beyond belief. Beyond belief. I just can't believe. I mean, I believe what I'm reading. You know, you must be a fake structural guy. All you guys in here must be fake structural guys. I apologize to that, because a couple of structure guys are no longer commenting anymore. They're leaving this out. They're bailing on it because I think they find these guys to be, well, either they gave up or they think it's redundant, they believe them, or they don't want to go against this group that attacks anybody that thinks that they're a crackhead. Here we go. This image here shows that this is the base. This is the number A. It's still in place. I'm going to show that there. And there's A again. And I don't know what the rest of the drawing is. This is probably pretty close to that. This is Tom. Let's see. Okay, there's notes. So JRS 87. I like what he did here. Is this his thing there? Yeah, that would be the counter. You just need to he removed part. He removed the base. He used some software and removed part of the rest of the diagram. This part. Too much liberty there. I'm out of here. I'm out of this one. I was just trying to find out one thing to prove to you guys the zero force member crap. And that's not going to happen in this lifetime, it looks like. All right, let me jump on to retaining wall to give you a little excitement now. Well, before I do that, let's see if I got any comments. We all love, thanks, North. I have your cat's name. George, yeah. Then number 2 would be racking. Number 2, racking. Yeah, I would say the same. I said racking in a video a long time ago, if you remember. And I thought it was going to stay there. You know, was it for racking reasons, overhang reasons? I did a couple of videos on each one, but number 2 would be racking. If you leave one in place, you think the other one would pull, right? I mean, just theoretically, it's a force being created, and I'm going to prove that in my video in just a minute. Let's go back to this. So the OSHA report, I got to give the rest of the background. So we saw how I just showed this. how this is sitting on top of the deck and 10 inches of it is sitting outside the deck, on top of just a single blister that gets load released. So you know what? Yeah, maybe I'll do the video now, and that way you can see it. So what I'm going to show, because this is missing, is that number, get over here, is that once you release the loads, and I'll calm down and just change my pattern of speech. When you release the loads here, it releases the clamp force here, but only B, because A is inside the deck. It's not part of our failure. So it's only B. As we can see, A is still there. B is the critical one. B is our critical one. Once B was released, it cracked like hell, they stated. Cracks came here. This was a downward, let's give us an arrow, and I'm going to take an arrow this way. This was a downward force, and I guess I could do a shear thing and all that, but only engineers would understand that one. So, ooh, I just came up with something, a downward torque, because we have different measurements here. So that did take a rotation. And what stopped this from falling all the way down, as I state, was that they only loosened this. Upon loosening it, the loads of this, the concrete resisted as long as it could, and then it cracked like hell. And I don't know if it was 15 minutes or instantly. What stopped the rest of the crack like hell to complete failure and probably killing everybody right then was that this bar was still in place. The plate grabbed and the nut grabbed up top. That stopped it from continuous and cracking like hell. Over the next few days, creep took place, developing into what we see the day of the photographs on the 14th and even the 15th. We see, and it developed just, not much, believe it or not, compared to what it dropped. At least the photographs we present or presented to us. Keeping that as my disclaimer on that, what we presented to us. And so we did have a torque action going on here. Why? Because the back of this guy here is only sitting on a single column, and it can 16-foot wide canopy. It did take a rotation. That rotation changes the torque and everything on this whole structure, running forces down 10 more so even. If it's already cracked like hell, that's the loads coming down here. We already know it lift up also because we can see into it. So that's already showing that it did like a little hinge action here, a little bending moment, and loads again coming down 10, as Denny Pate knew about. But he can't come forward and say, I know exactly what's going on here, because he's going to look like you should have stopped it then. You should have came up with something different, perhaps. They're going to, that might, his own confidence is bragging about it, put his ass in jail maybe. Sort of like the, what's his name? The black guy out in, that said the white people attacked him, the actor. Got away with it, and then they published it about how he's getting away with it. Now they're going back to court over that. They rubbed their noses in it too much, because he said he's going to, possibly sue or whatever the hell his stupid ass said. He took it to one level too far, rubbing his nose in it, and they said, "Oh, we got something for you. We're going to appeal it." As a police department, that was a major thing. I think that's the way it went down, roughly, whatever. So, nevertheless, if Denny Pate gets to run in his mouth, right now there's no prosecution being taken place. He get to run in his mouth, he can put himself right into a criminal case. So Denny Pate, if he's watching, he needs to shut his friggin' mouth up. If he wants to protect himself from going to jail. You better play dumb and let the public believe whatever the hell they're going to believe. And nobody's going to hire you anymore anyway, so what the hell you care? All right, so here are the forces coming down here. What happens if I just get rid of this? All right, forget number 11, forget all of this. This number 12 on its own. What? It's a dead load. It's in a girder. This is a girder at that point. Forget the deck even. Take the deck out of this formula. You're looking at a girder with a dead load with no reinforcement in this zone here. This dead load, this girder system, you would say, oh, that could cause a crack in the back of this guy here from the loads here. Okay, so now add some weight to it. Some weight, whatever we can figure out what weight's coming down this canopy. Now you see you get even more force in this girder right here. Now, I can state that this was very little bit of load loading down here, the shear that everyone keeps talking about, because it was cracked and it was structurally shit. How else could you say that? And the loads were coming down 10, as Denny Pate extrapolated, and as I stated forever in videos. So there is a load here. Now, if you guys say it's a zero force member, all right, you crackheads, it's zero force member. How much weight does this zero force member have? You know, all right, so tell me that. It's got some weight, doesn't it? How much of a load does it really have? Now, how much can this girder withstand since it's only and how much can this girder now withstand? Keep in mind that it was also taking forces now. Now you're going to put these back. Of all the weight of the deck, it's on top of shims only, transferring all the loads on the shims, not on a full base. So it now has, and it wasn't designed to transfer the loads on a shim. This was designed to transfer the loads on a full base. Okay, so now I go to my beautiful free body diagram again. Now I'm trying to show free body diagrams in real life. We're using sand and all this stuff like that. Let's go ahead and look at a free body diagram. My retaining wall that I put over here. Embry didn't comment. I don't know if he did or not. So let's play it. It's going to be 4 minutes of your life. So bear with me. See if I got any comments. Punch Embry in his throat. It's not a damn zero force member. It was zero force. I know. I know what you mean, Embry. I'm just I'm taking it as a troll, and then I said that. I know what you meant. Zero force. Yeah. So here we go. Watch this. Watch what I do here. And watch how I explain number 12.
Trying to ultimately get to the same failure. Let's see how soon it would get there.
So what I did was I loaded some pavers on top. I've got sand here, and I have a fabric between here to stabilize the soils.
So it's compressing, and I also have the balance of the wall down here now helping. The soil around it is pushing back. So to fairness, I got to cut that away. Here we go. So let me make sure you can see what I did. I don't want you to think I did any magic act. All right, so for fairness, I just cut it away similar to where it was without the balance. Come on, cat.
So I loaded. So this just has fabric here. This fabric right there. It's only 3 layers of it. Stabilizing the soil that it can stabilize in that area. It transfers the load in a solid capacity and a more solid capacity. Oh, I got to be out here 16 minutes, I think. 16 minutes, here we go.
The wall down here now helping. The soil around it is pushing back. So to fairness, I got to cut that away.
The soil around it is pushing back. All right. So we look here. What's pushing back from this falling down? Number B is pushing back, holding this in place so this can't push down and cause those cracks. Wait for it, though. Wait for it. I'll give you a little better shot of it. Better shot at attacking me. Hold on. Oops. Wrong video. Where'd you go? Here.
So let me make sure you can see what I did. I don't want you to think I did any magic act. All right, so for fairness, I just cut it away similar to where it was without the balance. Come on, cat. Don't come here now.
It'll be over within about 4 minutes.
You see the soils are compressing and doing its thing.
So the soil's in compression now. This is load bearing. So free body diagram, a computer program would show you right now that as I load this wall, this is becoming, let's say it has a ultimate failure, and say it's 100. Okay, just use a round number 100. Well, as I load this, I'm getting closer and closer to 100. And when I get to 100, it's going to fail. But internally, it's building up, but you cannot visualize it. This is what the programs do. This is the free body diagram, what engineering does. So right now, you can visual. So right now, I'm at whatever, 80%. And then when I get to 100, you'll see failure. Of it no longer can take any more. Well, 100 past 100. How's that?
I chipped one of them in that damn experiment.
That was it.
All right, it's already falling over to the right. I'm sort of.
So I'm stating it's falling over to the right, meaning here already, and I'm compensating with holding it, but I'm adding a stone any damn way.
I'm balancing it now. Here it goes.
All right, so you see what the free body diagram would look like if you were to do that, how it would fail even, based on the loads of the column also being at a vertical, not 100% plumb. Let's see if you can look at my thumbnails. You can see how it's kind of twisted and whatever. And this is literally how it fails based on also the resistance of the soil below. Behind it has more balance of soil. up here, less balance of soil. What I'm going to do next is I'm going to drop down some stone here, some of these pavers, and I'm going to resist this force by adding a load here.
It's gone. So I'm going to hold it in the air. Now let's count them up. So 1, 2, oh baby, it's still holding. I'm using a lot of counter force on it. 3, 4, 5, 6, 7, 8, 9, 10, 12, 13, 14, 15. And it's failed at 14 because 15 couldn't make it. You see what's going on there in the soil? I'm just helping it. I'm going to put it back a little bit and try to break it down. Now let's have a little fun and see if we can give the soil some counter forces around it.
So watch what happens here.
What happens if we give the soil some counter forces? Aha.
These are your counter forces that I'm referring to right now. That's the falling over. You'll see it in a minute, or you'll put it together on your own. The counter force from this falling down right now, causing the shear, is B. And when I release B, we get the failure. And you'll see it in my video here.
And we notice it compacted somewhat
Right
because I just ran that down into it. But, so I guess I should fairness, but no, let's go for it.
So in fairness, I should have broken up the soil, made it soft and fluffy again. But I'm saying, look, you guys just going to have to extrapolate that I'm going forward with a little bit more tighter soil than I started with, than a baseline. I'm adding pavers on top of the column right here.
We're at 4,
I can't count.
8, 9, 10, 11, 12. Let me grab some more.
You see now, I competitively can't count those damn things. Over 13, counting over 14 is just too much math for me. There we go. That's Embry's line. Too much math.
13, 14.
All right, I had some movement. You saw that reaction? I had a bit of a reaction. I'm going to add some more dead load counter forces on the base.
15, 16. See, we're coming about it differently. We're now we're countering it's pushing out forces.
I'm at 16, unless my counter's off. 16, and I had failure at 14 before, right? And I have these guys here, and watch what I do.
A counterweight, if you will. So we're at 2, 4, 6, 8, 10.
So the zone, this is number 12. It has a zone that is pushing against, all right? It has a zone it's pushing against, whether you like it or not. Even your fat ass when you're walking, you have a zone you push against the floor. So right here, this is a zone that's pushing against. It's still some load out here carried out to the end here, but it's only now acting as a scab, holding on like a little baby holding on to wrapping its hands around a human, a baby, a mama, a daddy, trying to hold on, help hold the loads in. And to help that baby hold on, somebody put a little rod through the baby's back and put a clamp there. Wow, that's terrible. And then clamp the baby on the back. But anyway, yeah, that got a little far on that one. So anyway, and so that's holding this force is counterforcing it. Wait for it. Wait for it.
And 12, 14, 16. I think it's close to trashing my camera. Let me.
I'm worried about it falling on my camera because it's unpredictable. It's unpredictable right now, but it will be predictable in a minute. I'm going to remove these and prove to you the forces will come that direction. I'm going to first counterweight a little bit. It doesn't have to be
17,
right.
18. Ooh. Hold on.
I'm at 18 now. Same damn soil. Look at the counter's off. 17. But I didn't touch it. I made sure to put it in the sand only over there. Add those
19.
I wanted to get.
We're at 19. Look.
Watch my
1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 2, 4, 6, 8, 10, 12, 14, 16, 19. Now, 19.
Check this out. So now we're going to remove the post-tension rod, number 11B. We're going to pull 11B out of this bad. 11B. My column is stable right now. Where's my 11B? Right. So what I'm going to do now is release 11B, the base. This is holding the base. This is holding us together down here, fellas. Now I'm going to release 11B and watch what's beautifully how it explains what you're looking at with the failure of the shear in the back of that diaphragm.
Let's remove some counter.
And when I say shear, it's a downward shear of 12, not that 11 crap.
Forces that prove my counterforce theory, right? One, don't hit me.
So I'm releasing the load, right? So detensioning the bar. Here we go.
Whoa.
There you go. It's simple as that. There you go.
8, 10, 12, 14, 16, 19. Now, 19. Let's remove some counterforces that prove my counterforce theory, right? One, don't hit me. Whoa. There we go. You put it back.
See what happened? So there's your fail. Now, it can't pull away because at the top, it's tied to the canopy. So where do the loads redirect to? They go right down where they can. They redirect to the diaphragm, and they cause the cracking in the diaphragm. Now, what would have saved it? The shims Danny Pate spoke of. It would have kept the loads, it would have transferred the loads back down into the pier. So you tell me who you're going to blame, guys. You're going to blame MCM for not doing the shimming, or you're going to blame Danny Pate for his engineering skills on this one. You tell me how you like to point that finger. Obviously, you can also point it towards Berger is kind of incompetent with their not knowing what the intent of the post-tensioning in number 2 would be. So you tell me what you think. MCM should have grouted. They're the builder. They should have understood the structure totally, along with BPA, which is a CEI, along with FDOT, along with everybody at the job site. Now, everybody wants to attack Danny Pate. He got in his car and he went to hell home. Or went to hell back to the office. All right. He went home. He did that.